Well, this is my project of mathematical computational mathematics. Well, anywho, this is the program that checks if a string is generated by a grammar. So let's try it out. We will run it with Python, and so it is asking for the variables of the grammar. Let's input the variables. They are correct. Now it's asking for the terminals. Let's input the terminals. They're correct. Now it's asking for the starting variable, which is s, and now it is asking for the rules. We first introduce the variable of the rules, and then its rules. So in this case it's AB and BC. It's correct. Now we will enter the rules for A, which are BA or A. Now let's enter the rules for B, which are CC or little b. And finally the rules for C are AB or A. We will not enter any other rule. It says that the grammar is inserted correctly. And now let's insert the string to check out if it can be generated by the grammar. So it says that the string can indeed be generated by the grammar. Which grammar? This grammar. Okay, now let's check out the code of the program. Okay, now let's look at the code of the program. So here is our main, let's say the main part of the program. So we first get the input, get the grammar from the input or from the user. Then we get the string to be tested, and finally we test the string against the grammar. So to get the grammar, we used, we wrote this. I wrote this function. I modified this function. Let's keep it like that. So we define our variables for the grammar. We get our variables. We get the terminals. Then we assign the start variable from the user. And finally, we read the rules by variable by variable, and we only return the start variable and the rules because that's the only thing we need to really have a complete concept of the grammar. Then we get the input string, and finally we test the string. So to test the string, we use the CYK algorithm. So this algorithm works by, it is a recursive function that computes for a given string and a grammar which role variables we need to use. So for the final string, it will get the rules or the variables of the rules to get to that string, and if the start variable is within those rules, we know that we can start the grammar and eventually get to the final string. And this CYK algorithm, as I said, it is a recursive function. Here it is. So it has a base case. When the string is just of length 1, it's just a character. It is very easy to calculate because we only need to know which rules produce that character. So we check the rules in the grammar for that character, and we add them and we return them. This table dictionary is just for caching the previous results and making a little bit more efficient the program. It's basically dynamic programming. Then, if it is not of length 1, it is at least equal or at least of length 2, we chop the string in various pieces to get many lefts and rights, like all the combinations of lefts and rights in the string, and we apply the algorithm to the left part and the right part to know what rules or what variables produce that substring, the left substring and the right substring, and then we pair both. Well, we make a cross product or with the left variables and the right variables to check if there are any rules that produce a combination of both rules. Well, variables, you know. So if there is, we add the variable that produce that combination of variables or that rule, and we do the same. So this is basically the algorithm. There is nothing else to it. The only relevant part is maybe the print grammar, which is just a function to printing in a pretty format the grammar, but yeah, that's all of it. Thank you.